Hello, my name is Carsten Samaschke. I'm CEO of Cloudical. And today I'm going to talk about SUSE Cloud Application Platform versus its competition. Before we do that, let me introduce you to Cloudical, my company. Cloudical is providing you with cloud-native services such as managed cloud services, migration services, development services, and knowledge services. We work on several regions in the world, such as EMEA regions, the Americas, and APAC. And we were awarded Best New Partner 2019 by SUSE DACH. We are SUSE Platinum Partner and SUSE Solutions Partner for Container as a Services platform, as well as Cloud Application Platform and Enterprise Storage. To learn more about us, head over to our website at https://cloudical.io. And now let's start with the session. In this session, we are going to compare several platforms and approaches to each other. We will have a look at Cloud Foundry, cloud vendor-specific offerings, Red Hat's OpenShift, and SUSE Cloud Application Platform. And we will compare those platforms regarding different aspects. So we will talk about idea and target audience. We will talk about CI/CD and platform as a service functionalities, support models. We will talk about and discuss about containers and Kubernetes-Support. We will have a look at their installation and on how build and deployment processes are working on those platforms. For each of the aspects that we compare, we will give points. So we will end up with a result which clearly depicts the best solution based on what we discussed up front. So let's start with idea and target audience. Let's have a look at Cloud Foundry at first. Cloud Foundry is a true platform as a services offering. It is an open source solution and it provides us with a community-driven approach. And the community is very huge, ever-growing, and includes some very interesting members such as SUSE, such as Pivotal, and other companies. Cloud vendors provide us with a different approach. They usually do not offer true platform as a service functionalities. What they usually bring onto the table is CI/CD functionalities with some mostly just minor traces of platform as a services. And the difference between CI/CD and platform as a services will be laid out in a few seconds. Mostly, those solutions are closed sourced solutions, so you do not see the source codes and you are not able to modify them and work with them according to your needs. Red Hat's OpenShift, on the other hand, is a CI/CD solution which is marketed as platform as a service. We'll come to that in a few seconds as well. Different than the cloud vendor offerings, OpenShift is open source, and that gives you more freedom and more opportunity to tailor it to your needs. SUSE Cloud Application Platform is an enterprise Cloud Foundry distribution. So it brings all of the advantages of Cloud Foundry and adds enterprise-grade support and a development team which is basically taking care of everything under the hood. It is providing us with true platform as a service capability similar to Cloud Foundry. And as I already pointed out, it is based on the open source Cloud Foundry versions and is adding more value on top of them. Having said that, let's go to the results of this category. So Cloud Foundry gets 1 point because it is an open source project and provides us with a lot of platform as a service functionalities. The cloud vendor specific offerings are mainly closed source and mostly centered around CI/CD, so they do not get any point here. Red Hat's OpenShift gets a point because at least it is open source, so you can tailor it to your needs. And SUSE Cloud Application Platform is an open source based solution. It is based on Cloud Foundry, so it definitely gets a point here as well. Now, we already talked about CI/CD and platform as a services capabilities, but what is the difference between those both aspects? Let's have a look. First of all, let's talk about CI/CD. The traditional approach with CI/CD is that you create your own build pipeline and you are in control of the pipeline. So you create it and you manually define all the aspects in there. You are in charge for the build pipeline. So there's a lot of work involved there. Such a build pipeline or multiple build pipelines enable you to have continuously running build and deployment processes. And that is basically the idea of CI/CD. You have a solution in place which is centered around deployment. And that is a value on its own. Although compared to platform as a services, it is just the basis. Because platform as a service solutions provide us with CI/CD capabilities and they add on top. They add, for example, automated build pipeline. So you do not need to take care of how to build things. The platform knows how to build. And the platform provides us with abstraction from the underlying infrastructure. As a development or as an operational team, we do not need to take care of that. We just work with it. So we just deploy. And that is another very fundamental aspect. With platform as a service, you have way more automation compared to CI/CD and obviously compared to manual approaches in regard to deployment and operations. So the true strength of platform as a services is that it goes one step beyond what CI/CD offers. Having said that, let's compare the four competitors in regard to CI/CD and platform as a service capabilities. Cloud Foundry, as I already said, is a platform as a services offering, and it provides us with so-called build packs. Those build packs are basically the component that is able to take source code and transform it into operational binary code. Build packs are available for different languages such as Java, .NET, Go, and so on and so forth. And you basically have an automated and opinionated build process. So the platform, as I already pointed out, knows what is best for your solution. Obviously, it provides platform as a services capabilities, so it abstracts you from the underlying environment as well. Cloud vendors usually provide us with the option to create self-defined build pipelines. So we are in charge to create them. So that is typically just CI/CD capabilities. Again, not a bad thing, but compared to platform as a services, to true platform as a services, that's just the foundation. And you need to build upon that on your own, which involves a lot of knowledge and a lot of work. Red Hat's OpenShift, then again, is a CI/CD offering as well, or provides us with CI/CD capabilities. So you have those self-defined build pipelines. You have your build server built in. By the way, the built-in build functionality is based upon Jenkins. SUSE's Cloud Application Platform is basically Cloud Foundry with an extra or with several extras. So you have your quality assured build packs with SUSE Cloud Application Platform. So it's basically community build packs and build packs that were looked upon by SUSE engineers. You have those automated or opinionated build capabilities, and obviously you have those platform as a services capabilities. So when it comes to CI/CD and platform as a service, we will give Cloud Foundry 1 point. The cloud vendors will receive 0 points. Red Hat's OpenShift will receive 0 points. And SUSE Cloud Application Platform gets 1 point. Again, that is not to say that the functionality provided by cloud vendors and or Red Hat's OpenShift offering are bad by any means, but Cloud Foundry offers more. So that is basically why we gave 1 point for the Cloud Foundry based solutions and 0 points for the other ones. Now let's have a look at support models, because you want to run your workloads in a productive environment. So you should have support for that, right? Let's again have a look at Cloud Foundry. Cloud Foundry is a community-driven project, and as such, it just provides you with community support. So the community is definitely awesome. It definitely helps you. It gives you a lot of insights, but you do not have production-grade support, and that is a bad thing in that regard, because if you are running your workloads productively, you want to have someone who answers you in a given time and not basically based on their personal or private availabilities. That's not to say that community support is bad, not at all, but in a production-grade environment, you want more. Cloud vendors can provide us with commercial support according to service and support level agreements, and they can give us production grade support as add-on. So you can basically invest a lot of money into their support and get then answers within an hour or so, basically depend on your service level agreement. The same is true for Red Hat's OpenShift. So you have commercial support as well as production grade support. And then again, that is true for SUSE Cloud Application Platform as well. So you have commercial support and production grade support. And again, you still have the option to default back to community support. So you are not forced to interact with a representative of one of the cloud vendors of Red Hat or of SUSE if you don't want to. But having that opportunity is very important for commercially run applications. So you should take that into consideration whenever you look for commercial options. So Cloud Foundry, therefore, just gets 0 points. The cloud vendors, Red Hat OpenShift, and SUSE Container as a Services Cloud Application Platform, my apologies, they get 1 point each. A problem why I just mentioned Container as a Services Platform was because I was actually already thinking about containers and Kubernetes. But before we compare the different platforms there, let's discuss about containers and Kubernetes. So containers, which are one of the major hype things currently, are quite obviously something that is to be considered when talking about a platform as a services solution, right? Containers are so popular because they provide us with a very lightweight abstraction from the underlying environment. If you compare that to traditional virtual machines, with a traditional virtual machine, you basically emulate a computer. And containers basically are more like processes that you virtualize. So basically more like, you better compare them to like a traditional kind of application you start on your computer. So you are not emulating a whole computer, you are just starting an application on your computer. And that basically is the reason why containers compared to virtual machines provide less overhead. And that's fundamentally less in that regard. So basically you can utilize the available resources way better when working with containers. And since they provide a lightweight abstraction from the environment, from an applications perspective, you still have the same advantages as you would have when working with a virtual machine. So you have a well-known environment for your application. The application basically knows what to expect and where to expect things. It knows about the operation about the operational system. It knows about which tools to call or whatever. So it is basically a well-known environment to an application, similar as with a virtual machine, but with a lot less overhead and way more lightweight. The complexity with containers comes basically because of their advantages. So if you have the ability to run containers, you will not run just 2 or 3, usually with a professional application, specifically not with a cloud native application based on microservices. In regard to those applications, you will mostly and more likely to run like dozens or hundreds of containers at the same time. And that gives you a lot of challenges because you need to operate them, right? And that is the place where Kubernetes comes into the game and where Kubernetes basically proves its value, because Kubernetes orchestrates containers. So it takes away all the complexity in regard to deployment and operations. It knows about its environment. It knows about available worker nodes. It knows about their load. It knows about which worker nodes might be suitable for which workload. And Kubernetes basically takes care of all of those things. So it provides us with a lot of abstraction, and it provides us with high availability scenarios. So you are able to run your containers in HA scenarios, allowing you to basically have failover scenarios laid out and to do updates without any downtimes and so on and so forth. So Kubernetes does a lot of the heavy lifting, and it provides us with built-in security. So there's a lot of things that basically speak out for Kubernetes, and ultimately you want to use something like Kubernetes in your operational environments. You definitely want to do that. Although Kubernetes comes at a cost. It has a very, very steep learning curve. So you need to be aware of that as well. Having said that, let's then again compare the different platforms in regard to container and Kubernetes support. Cloud Foundry was traditionally not known for any kind of Kubernetes support. Actually, just the latest iterations runs on Kubernetes, so it is brand new to the Kubernetes world. Older Cloud Foundry versions were basically based on a proprietary solution for running Kubernetes. That proprietary solution was called Diego, and the Diego scheduler is pretty well known for being very complicated and not so reliable in regard to container management. Cloud vendors, on the other hand, they provide us with Kubernetes and container support per their build pipeline. So you can basically create your build pipeline, and you can bring in Dockerization and containerization approaches and deployment approaches to your Kubernetes platform. But speaking of Kubernetes, they tend to just support their own specific Kubernetes dialects and Kubernetes distributions. So that might be a problem. It's not to say that your application won't be running on other platforms, but if you want to, for example, build something on Azure and then deploy that to a Google Container Engine-based environment, there's a lot of work to be done in that regard. So you are limited to what is possible with which cloud vendor specific offering. Red Hat's OpenShift, on the other hand, is a Kubernetes distribution. And that is very important because that adds a lot of value to the proposal. So since OpenShift is Kubernetes, it has all the advantages of Kubernetes built in. It provides us with Helm deployment. So if we are able to use Helm Package Manager as a source of application deployment, and that basically allows us to get rid of many of the complexities related to application deployments with Kubernetes. So you can basically roll out very complex deployments using Helm with just one command, and that is a value on its own. Internally, it uses Jenkins as CI/CD platform, and Jenkins definitely can create containers, so there is support for that built into Red Hat's OpenShift. SUSE Cloud Application Platform basically brings together most, if not all, of the good approaches found in other platforms. So it runs natively on Kubernetes. It supports Helm deployments, and it has support for container creation and for managing the life cycle of containers. So it basically, again, adds on top of what is to be found with other platforms. Having said that, we then can again give some points. So Cloud Foundry gets half of a point because the latest iteration supports containers. Previous iterations, not so much. Cloud vendor specific offerings get a point because they have a lot of Kubernetes support built in and container support built in as well. The same is true for Red Hat's OpenShift as well as SUSE's Cloud Application Platform. So if you think of that, and if you are now sure you want to run one of those platforms, you need to take care of the installation process. So let's talk about that now. In regard to the installation, Cloud Foundry is pretty famous for being complicated. With older versions of Cloud Foundry, you could typically have a day or two invested into just setting it up. It was complicated. It was even more complicated. That has changed in the current iterations with the introduction of Bosch Lite. But still, the installation process is not the traditional strength of Cloud Foundry. So complicated describes it best. And that's basically a huge difference to what you can find with other providers, specifically the cloud vendors, because there the installation process is straightforward. You just do your provisioning via your portal. Perhaps you have a CLI, so you can basically roll out the specific build and CI/CD solution from your command line, and that is it. It typically takes half of an hour or an hour maximum until everything is there. Usually it takes more, like around 5 to 10 minutes. With Red Hat's OpenShift, you would use Red Hat's specific and proprietary OC install tool, which comes bundled with OpenShift. So it's basically just installing OpenShift and then adding CI/CD capabilities on top. So it's pretty straightforward. And then again, the same is true for SUSE Cloud Application Platform. And that is why you want to choose an enterprise-grade kind of Cloud Foundry solution over the community-based one, because SUSE Cloud Application Platform is containerized. You just roll it out using Helm charts. And it is a very, very simple install on SUSE Container as a Services platform, as well as other Kubernetes environments. One more aspect, which is not noted down here, but which is interesting, SUSE Cloud Application Platform runs on all of the major cloud vendors' platforms. So you can basically use Google Container Engine, Amazon's EKS, or Microsoft's AKS Kubernetes services as your underlying foundation for Cloud Application Platform. You will get support and you will get an installation description on the SUSE website. Having said that, let's compare then again the outcomes. So Cloud Foundry, since it is complicated, gets no points at all. Vendor-specific solutions get a point. Red Hat's OpenShift gets a point because it's a straightforward install. And SUSE Cloud Application Platform gets a point as well, because then again, installation is perhaps not easy, but simple and well described. Now, let's come to build and deployment processes. And I divided that section into 3 subsections, so it is a little bit more, it's a little bit easier to follow upon the different things I'm going to say now. So, in regard to build processes, Cloud Foundry is a platform as a services solution, and its major strength is it is able to just detect the programming language and therefore the build approach based on a source code. So you do not need to define anything in regard to build processes. It is done in an automated way. You can nonetheless use a manifest file for customization. So you can basically tell Cloud Foundry what to build, how to roll it out, and so on and so forth. And the build process on its own, it's done using a thing called Community Build Pack. That's basically a solution to grab code, compile it, and then roll it out according to the manifest. So you can add additional functionalities. You can even create your own build packs, and they would then be triggered by adding code to some specific location, and then all the automated stuff would happen. Since cloud vendors traditionally support CI/CD approaches, you would be required to create cloud vendor specific build and Docker/containerization description files. And you would be required to manually define your build pipelines. Quite often, you also need to provide your application with specific manifest. So there's a lot of things that you need to do to get something being built. The same is true for Red Hat's OpenShift. You would usually manually define your build pipeline. You can obviously use already predefined ones being available with Jenkins. But nonetheless, the definition and the maintenance of those build pipelines is extensive and can prove to be complicated. Development teams, they usually love the idea of having something that builds the environment for you, but they don't like to do that on their own. They don't like to manually roll out things. And then we have SUSE Cloud Application Platform, where you basically have the same advantages as with Cloud Foundry, since it is a Cloud Foundry distribution. So you have the automated detection of the programming language. You can use a manifest file for customization, and you can the community provided build packs, your own build packs, as well as SUSE provided build packs. So you get, then again, something on top. Now, let's again give some points. Cloud Foundry gets 2 points because it provides us with an automated build pipeline, and it allows us to customize builds according to our needs. The cloud vendors get 1 point because you are able to define your own build pipeline and to maintain it. The same is true for Red Hat OpenShift, and SUSE Cloud Application Platform gets another 2 points because all the advantages of Cloud Foundry apply here as well. Plus, you get the SUSE approved build packs. Now, once we build things, we want to deploy those things, right? That is again where you have several options, and we start by looking at Cloud Foundry. Cloud Foundry is able to deploy and to run application binaries as well as Docker images. The cloud vendors traditionally are able to run application binaries as well as Docker images. Red Hat's OpenShift is able to run Docker images and pods as well as Helm charts. So it basically is not able to run application binaries as binaries. You always need to containerize your application. And SUSE Cloud Application Platform basically brings all of the nice things together. You are able to run your application binaries, you are able to run your Docker or container images, and you are able to use Helm charts. So you get the best of all of the worlds here. That gives Cloud Foundry 1 point, the cloud vendor specific offerings 1 point, Red Hat OpenShift 1 point, and SUSE Cloud Application Platform gets 2 points because you have the most options here. And now let's talk about deployment tools. With Cloud Foundry, you usually use CF command line tool plus the push command there, which basically brings your workload into production. With the cloud vendors and their Kubernetes offerings, you would use kubectl as well as the vendor dashboards. With OpenShift, you would use kubectl as well as the OpenShift dashboard. And with Cloud Application Platform, you would use CF push as well as the so-called Stratos dashboard, which gives you another option to basically define your workloads and deploy them. Again, let's do the number crunching here. Cloud Foundry gets 1 point. The vendors get 2 points. Red Hat's OpenShift get 2 points. And SUSE Cloud Application Platform get another 2 points. So, where does that leave us? Has anyone done the mathematical calculation? Well, I did. So we end up with Cloud Foundry having achieved 6 points. The Cloud Vendor specific offering 7 points. Red Hat's OpenShift has got 8 points. And the SUSE Cloud Application Platform got 11 points. So is that basically the answer to everything? Well, the world is not that easy, obviously, right? So you would definitely look into what makes sense for you, your organization, and your requirements. But the interesting aspect is that SUSE Container as a Services platform combined with Cloud Application Platform would give you everything that you get from other platforms, plus an easy rolled out platform as a services solution and a lot of automation. So it makes a lot of sense to look into that platform, and an increasingly number of customers and potential customers see it the same way. So what we see as Cloudical is basically a trend towards those platforms, and we highly encourage you to get in touch with us and with SUSE to ultimately raise the bar and to find the best solution to your needs, because SUSE Cloud Application Platform is a very, very awesome platform. It's actively developed and it gives you the best of all of the worlds. Having said that, I thank for your attention. Looking forward to your feedback and see you next time. Thank you.